Okay. Welcome, folks. Welcome. Trickle in. Find a seat. Get ready. Use your brains. And to pull real fast. Okay. Welcome back from vacation. That was an enormous amount of time off. And what that did was it ruined my class. Because my class, 45 minutes of lecture already. And so you should expect a delay in the due date of this next homework that's due on Saturday. Probably to Wednesday. I'll do it right after class. I'll delay it. Everyone tell me if you're ready to concentrate in the poll right now. All 16 out of 33 students. Go ahead and do that. 50%, not bad. Not bad. Okay. So, yeah. We're going to have a extension of the deadline to next Wednesday. Today's office hour. Today there will be no office hours. No office hours today. Because this assignment will be due next Wednesday. And so next Wednesday's office hours will be way more heavily attended. And where's my boring streamer music? There it is. Awesome. Okay, so next Wednesday will be heavy. I don't want to do office hours if there's no one showing up, and that's basically what happened last time. So next Wednesday, much more effective office hours. Wow, everyone's ready to concentrate. All 11 out of 16. Okay, new topic, meaning new integration technique this week. So I'm going to begin now. Okay, so this topic has a name. It's called partial fractions. That's the name of the topic. And I'm now going to go through and tell you what it does, how to use it, some simple building block situations, and then I'll execute an example without even telling you how to do the whole thing in a note card beforehand. Because it's just through the example that you'll learn the ropes. Okay, so that's the plan. I gotta go though. I gotta just get on this. Oh, Gath is here. Gath is a great luminary who should be immediately... We don't have one of these bots that immediately shouts people out. There you go. Great chemistry professor. Awesome. Okay, so go check Gath out. Oh, and she's now teacher's pet as well, so she can do no wrong except for interrupting the class in the beginning and just delaying, ruining, like eating up. So now we don't have 45 minutes. Thanks to Gath, we have 40 minutes. Everyone thanks to Gath. Okay, teacher's pet. Great. Thank you for doing that. Okay, next, let's begin. Number one, what the heck is the context? The context. Write this down. The context where partial fractions emerges. The context is simple. Can we integrate? Can we find antiderivative of a fraction where you have a polynomial divided by another polynomial? Like this. Oh, one polynomial, very complicated. Oh, x, I don't know, plus 3, 2 plus 1. Wow. Divided by, I don't know, x squared plus 5x plus 6 or something. Wow. Crazy. Crazy polynomial. Okay? Right now, our tricks don't help with this polynomial. You can just believe me on that, or you can be a good student and actually go try this while you're learning the new technique. Also try it with old school techniques. You will run into many brick walls. So the question is, can we integrate a polynomial divided by another polynomial? And the answer, the ultimate answer, yes. Like barely. So fractions of polynomials are in the pale blue dot. Remember that the main theme here is, what do we know and what do we not know? That's actually your whole all of college. That's what you're doing. And we're looking at the math, the integration corner of that little question. So are fractions of polynomials, are they in there? The answer is, with great pain, yes. Okay, just barely. All right? That's the context. That's the overall situation we're trying to deal with. Good. I just expertly dealt with what is the basic question. Write that down in your notebooks, note cards. Okay, and highlight it. Now I'm going to explain to you the slogan or the overall strategy. Now I do this, okay? I have 45 minutes, 40 thanks to Gath. All right, so part 2. How to do this? All right, how the heck do you do something like this? Okay, here's the strategy in bulk. Like, here's what you'd find at Costco if you went to the integration map. The bulk strategy, bulk. Here's the slogan. The technique is to break the big scary fraction into the sum of small little adorable fractions. Big scary fraction. Big scary fraction. Trade. So much of integration involves a trading off for a simpler problem. As you see, I have expertly explained this in the previous perfect lectures. Big scary fraction, trade for little sensible fractions. Little cute fraction plus another little cute one. Fraction plus da da da. Okay? And now it's a trade. So it better be the case that the purple fractions are easier to integrate than the big scary fraction. You crumble this fraction as a sum of other fractions. Okay? And thank you. Yeah, words just flow perfectly. That's the strategy. I just wrote for you the strategy. Here's the picture of the strategy. Okay. I want you to remember from middle school or something? I don't know when. In algebra class, you were often asked to add two fractions. And you had to combine or you had to cross multiply and put everything on the same denominator. Go dig up that note card. You'll know what I mean when you see it. You'll see this thing. You'll see this two arrows like this. And then you're supposed to know what to do. Yeah. So you're used to combining little fractions and putting them all in one big fraction. That's the direction of math that you're used to. But what we're gonna do is purposefully take a big scary fraction and split it up into a sum of friendlier ones. So it's gonna be, in some sense, the opposite mental exercise as you did in 7th grade note card number 437B. Okay? So it's gonna be the opposite neuron firing. And that's gonna cause a little bit of friction, a little bit of fun. Okay? So I just expertly knocked down overall strategy. This should be absolutely clear to everybody in my class. All 22 of you who are here out of the 33 people. Welcome. Labor Day was a little bit extra laborious, I guess. All right. Number 3. The building block situations. So at the end of a partial fraction decomposition, when you've executed the decomposition and you've got your little friendly fractions, we need to make sure we understand which fractions are immediately friendly to us and which fractions are still big and scary. Okay? So I'm gonna do some of the most basic building block situations now for you. Okay? So here are some great, wonderful types of fractions that we can immediately write down the integration answer to. Okay? So wonderful building block easy examples. Okay, first one. I'm just gonna bang them out. First one. This one should be just second nature. Boom. That's a fraction. That's a polynomial divided by another one. Fraction. Done. Boom. And we know how to do it, really. A trig substitution. Right? It's a trig substitution. Boom. But this particular one should be second nature. It should just be memorized by now. And if you alter it a little bit, slight, we know how to deal with those too, expertly, because you did last week's homework, right, folks? This, I'm not going to write it out because it'll confuse you. However, this is a trig sub. X equals 2 times tan theta. Okay, and then go. And going is easy now. This is easy. Meaning, it is a blue integral. It's doable. You just have to make sure you put the 1/2s correctly everywhere, and you do your dx and do it properly. Don't forget the 2. And that's it. It's gonna respect them at the end and bring it all back. It's gonna be arctan something. It's gonna be blah 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 numbers arctan blah 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 x plus c. It's gonna have this shape. Friendly. It's just totally nothing to worry about. A little bit more alteration. Oh, sorry. Sorry, it had a 1 up there. I really meant 15. No problem. Just 15 times this. Know what is a slight alteration and what is a fundamental change. That you need to learn from practice. But you see, 15 over x squared plus 4, fundamentally arctany. We're going to call this arctany. Got a little bit of arctany. Arctany? All right, that's this kind of situation. 2. Here's a slight, it looks like a slight alteration of the previous one. 3x over squared plus 1. Here's an example. Okay, this is not arctany. Not arctany. It's not arctany. Because this gets... who's an expert at this? We know who the expert is here. The class, please consult our resident expert here. He's both an expert at what I'm about to say, and he's not on Discord, so he must be playing. I see. So when he plays video games now, he makes sure not to he makes sure to turn Discord off while he's playing his video games. Or he just stopped coming to class because the video games consumed him. Or he's this person named Kotz who's playing Albion Online. I can see that you're playing Albion Online, Kotz. Is that Chizonin? Is that also Chizonin? Okay, well, I was gonna say the resident expert is, please consult Chizonin. Big cheese about this integral, because this integral is knocked down with an ordinary substitution. Substitute. U equals x squared plus 1. Du equals 2x dx, which is just a slight number off of 3x dx. That's why it works. And so, dot, 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 I let you fill this in. Go ask Chizonin how to fill this in if you're having trouble still. You'll get ln 1/2 times 3. How am I so good at this? Yeah, I practice. X squared plus 1, like this. Absolute values are unnecessary here because x squared plus 1 is always a positive quantity. But just so that the note card people are happy, and just stick the absolute value in. Okay, this plus c. Done. Boom. Boom. Okay? This is a substitution problem. Just ordinary substitution. And look at the type of answer you get for this kind of fraction. This kind is ln. 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 Okay? Look at that. This fraction, its answer was totally different looking than this species. This species is an arctany fraction when you integrate. This one, ln. Ln. Okay? Third building block that you need to absorb. It's an experience. You're collecting simple first experiences because the entire whole story, when you have a huge polynomial divided by another huge polynomial, will ultimately, by amazing magic, will crumble into a bunch of arctany and ln examples. These types of building blocks. Let me do one more quick one. Quick. Oh, 4 over 3x plus minus 7. Just a simple little linear fraction, linear polynomial on the bottom, number on the top. How to deal with this? How to get around this? Okay, this is again an ordinary substitution. Chizonin knows this. Chizonin and Kotz, who might be the same people. Let me check. Let me just investigative journalism. No, they're not the same person. So Kotz probably doesn't know this because they're still addicted to their video game. So Chizonin alone understands this example. You do u equals 3x minus 7. Cordon off that whole bottom, and then you get du is just 3 times dx. Okay? And I will write you, when you translate to use and translate back, go ahead and do this for practice. You will get 4 thirds, 3 comes down in the bottom, ln of 3x minus 7. Now the absolute value is needed because that thing can be negative. Okay, so there you go, plus 4 billion. Okay, boom. Also ln. Okay, so if you're in this kind of situation, good news. You know it's gonna checkmate in two moves. Checkmate in 2 moves. Checkmate in possibly 3. I don't know. It's soon. You've arrived home. You're squarely in the safe zone. That's what we're collecting. When do you feel safe? And when do you feel, oh no, what the heck do I do now? Notice here, this doesn't fit any of these. Any arctany. It's not, it doesn't look arctany. It doesn't look eleni. Arctany? Eleni? How do I deal with this fraction? It's not anything. It's not one of my 3 basic building block experiences. Let me give you a 4th experience real fast. 4th little experience to build off of. 4. I'm gonna just alter this integral, this ln one a little bit. Okay? Okay. What if you had like 3x over 3x minus 7? Okay. Well, hold on. Hold on. It was actually really important when Chazonin will understand this. Someone who has practiced U substitution, which every one of you have to be practicing, of course, will understand that there's a fundamental different flavor from this problem versus this one. That 3x on the top, the x part, screws up our substitution big time. Okay? However, there's a trick here. Trick. It's called division. I want you to learn this little lesson from this example. Division will help us here. Okay, how does division work? Division works like this. You put the bottom one on the outside of the division symbol. So this is probably like one of your earliest note cards, except you probably had numbers dividing other numbers. If you go back to note card number 13, part 2, you will see all this division stuff, but they were probably numbers. But the great thing is division works the same way with polynomials. So you got the thing you're dividing into, and then the thing you're dividing. So you put this part here, up here. 3. No, wrong. Put it way in here. 3x. Okay, now what you ask is, how much polynomially? So I get to use powers of x, positive powers of x. How much do I have to multiply 3x minus 7 by to get as close to 3x? The answer is multiply by 1. Don't multiply by x. You'll overshoot. You'll get 3x squared, which is nowhere in this, is too big for this inside polynomial. So multiply by 1. Now do the multiplication. 1 times 3x minus 7. And then subtract. Follow your notes from note card 13.2. Follow that where there were just numbers. Okay. Now you do this. 3x minus 7. Okay, so the total here is 7. The minus sign distributes, folks. 7. So 7 is my new thing that I'm trying to get 3x minus 7 to go into. That's how division works, folks. So now I have to look at this versus that. Okay. I can't multiply 3x minus 7 by anything nice, anything that's just a polynomial, positive powers of x or constants, no negative powers of x allowed. I can't do that because if I multiply by anything, I'm going to have at least x's still. So that means 7 is the remainder. This is too small. Its degree is smaller than 3x minus 7. So I stop and I put this remainder over 3x minus 7. So 3x divided by 3x minus 7 is one whole number plus the remainder, which is just the number 7, divided by what I'm dividing by, 3x minus 7. This is a true fact. Your original fraction, scary, is actually this sum of two fractions. This is not an instance of partial fraction decomposition. This is an instance of division. So we're going to call this go and divide. Do some division. That's what we're going to call this experience. Do division and trade off the integral. Look. Big old friendly 1. So now this equals friendly plus and the point is this is big happy friend, of course. It's just x plus c, x, I mean it's just x, dumb, yeah. But this one, chat, why don't you interact with me a little bit for once? Chat, what kind of experience is this one? Chat, is it arctany? Is it? Yes. We have a name now for these experiences. It's a U-sub, correct. It's Eleni. Macaco 446. Eleni. Shrek. Eleni. Just human guy. Eleni. Hot tamale. Don't feel like it. Okay. Math guy. Eleni. Math mama. Eleni. Rack. Eleni. Flush throne. Eleni. Absolutely. Eleni. Meaning we're safe. We just do our simple U substitution, as everyone was saying, the smart people were saying first, who don't want to say stupid sounding things like Eleni. But the point is to reduce to a problem you've already solved. Grand principle. This is a general principle, right? We're gonna have to really center that. Overall, are you reducing to a problem Overall advice, general principle. Are you reducing to a previously solved situation? And what we just witnessed is, I don't want to go and do it. I know I can. I'll let you practice the doing of this 7 over 3x minus 7 U substitution. It's rote, procedural, simple. But the point is, this example, which wasn't Eleni to begin with, got there by division. Do some division and you can extract out the true essence of the problem. The true essence of this problem was in this part. This 7 over 3x minus 7 problem is in some sense, the true essence of this original fraction problem. You can reduce to that other one. Okay? So that is I seem to have caused some discomfort in the chat. So Tori Finnegan is fed up. That seems to be their normal state. Who else is fed up here? Just a human guy, yeah, also tends to be somewhat of a negative person. And what else? Who else? My ears. Okay, that's my brother. Always, complaining. Okay, good. I'm trying to give you guys life advice here, and this is what I get, right? Right? Okay. Jan, that question is a good question, but for example, what we're saying is not that. So Jan, we are not saying that 3x minus 7, you can plug anything in and it makes sense in the denominator when you look at this trade-off. But what we are saying, Jan, a good question. What we are saying is, Jan, if you do go do the algebra on right-hand side, right here, in this purple box. Go and add those two things and combine it into one fraction. Jan, what we just did was say, if you do that, you will get the left-hand side, just as an algebraic identity, an identity between two algebraic expressions. We're not asking whether, for particular x's, does this side make sense or not? No, you're right. For particular x's, once things will not make sense, but for all other x's, you will get a perfect identity. Left side equals right side. So these two algebraic expressions are the same expression. That's what we're focusing on, not whether you can always plug a particular value of x into the left and right side. Interesting question. I've never thought of that confusion, but it's an understandable one. Okay. All right. We are simply crumbling one algebraic expression into simpler pieces. That's what we're doing. We're not really we're not worried about specific x's that ruin the whole story. We're thinking about all the other x's that make the expression successful. Yeah. Yes, Jan. But Jan, that's a perfect way to explain it. You are trolling. You are a great master. Great. Everyone, ask Jan your questions. Right. Exactly. Kappa Klaus is real. All we're saying is if you do the right-hand math problem, combine denominator, blah, 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 combine like terms, you will, and simplify, you will get the left-hand expression as just an algebra math problem. So we can trade off one for the other in the integral. Fantastic. Okay, so building block examples. Very important you understand them. You gotta have a sense of arctany. You gotta have a sense for ln. This is an example of an ln. This is also an example of an ln. And then here's a situation where you can, looks like it's not ln or arctany, but with division. This is called division, long division or something. You can bring this situation down to essentially ln. Okay, so now I will go back and tackle, without showing you how, or the exact 14-step thing, I'm gonna just dive in and show you how to deal with this crazy first example. Okay. How to deal. And I might, it's 12:04, so I have 10 minutes. I'm going to go slowly so that you have this, me doing this. You have an example that you can refer back to even after I've officially taught you in the next 45-minute chunk how to do it. Okay, so I'm going to just proceed and show you some magic. I'm going to do some magic. How to deal with this. It doesn't look arctan-y, doesn't look ln-y, and it doesn't look division-y because the top is smaller in degree than the bottom. The bottom is x squared-y, the top is xe. It doesn't go in. The division's not going to even start. You're not even going to be able to start dividing. None of the techniques have worked so far. So let me go dive right into that one. Dive in. Here's what I'm going to do. So it's red. It's this integral is bright red right now. It's very scary. Oh, sorry. All right, here we go. So for note card people, step one. Step one. I'm just talking to myself. I don't actually do steps. I just go. Okay. Step one. Factor. Factor is mentioned here. Factor. Right. Yes. Right. It would have been really nice if some of these things canceled, but I chose such a bad example that there's no canceling. So why did I factor? What was the point of factoring? Jeez. Sounds terrible. Don't combine it again. No. Don't do that. Because now you do some magic. Step two is magic. Today it's magic. Magic right now. Take this fraction. We have our, this is what I'm trying to integrate. Magic. I'm going to try to magic it so that I've got myself, magic is what color is magic? Magic is purple? No, blue, bright blue. Hunt for two magic numbers. This is what I'm gonna do. I'm gonna try to take my big scary fraction and I'm gonna crumble it. I'm gonna magically try to crumble it into a number divided by x plus 3 plus a number divided by x plus 2. Where did the x plus 3 and x plus 2 come from? It was informed by these factors. Okay. So I'm going to find a plus b. I'm going to try to find these. Okay. I'll just pretend. Do a little bit of pretending. Pretend that this is, I had it. Pretend I had left side equals right side. Pretend this was somehow decomposable. SAT word. Decomposable into this way. I will now cross multiply. Crossy? I don't know why I wrote crossy. But crossy this multiply by x plus 3, so times x plus 3 times x plus 2 on both sides. So go ahead and do that. I'm going to do that. Left-hand side becomes x plus 1 equals. Right-hand side, when I multiply by the product, it's going to cancel x plus 3 and have only x plus 2 left. And then, when I multiply by this product of the two, the x plus 2's will cancel and only x plus 3 will be left. So I arrive at this equality. I'm pretending. If I had my a and b, this would end up being true. Collect like terms now. That's one way to do it. One way to do it is to collect like terms. So let me write that as a branch off, okay? Here's one way to do it. I could collect like terms, but I'm gonna do a secret, top secret second way. And you will appreciate this afterwards. Secret. I'm trying to make this true. I'm trying to make the left-hand side be identically equal to the right-hand side for all values of x. So, I'm now going to cleverly plug in at this stage, when there are no denominators in sight, Jan, I'm going to plug in x equals minus 2. I would get minus 2 plus 1 equals a times 0. Good. Plus b times minus 2 plus 3. Fascinating. Let's see what this says. This says minus 1 equals b. Wait, it just spit it out. Right in front of you. Look, just like a magic trick. Pew. B is minus 1. It's half the mystery is gone. Found B. Wait, so is this dream actually gonna come true? Half of it, I've already puzzled out half of this decomposition. Maybe it's gonna work. Maybe there's hope. Now, how to tease out A? I'll do secret number 2. Second secret. Plug in. I'll do it in a different color so that the note card people get confused. Plug in. X equals minus 3. This time. On both sides of this wishful thinking, I dream a dream equality, on both sides of this, this fantasy, I plug in x equals minus 3. Then I'd get something, what do I get? Minus 3 plus 1, left-hand side equals a times minus 3 plus 2 plus b times 0. That's really good. Multiplying by 0, don't even have to think about it anymore. And so you get negative 2 equals negative a. Okay, it didn't come out just bam right at once, but I hope you can go from here to deduce that a is therefore positive 2. Boom. Found a. And notice, by some conspiracy, the universe gave me only one pair of possible numbers that could possibly have made this work. It spit out precisely that b has to be minus 1. Your hands are tied. And a has to be 2. There's no other option possible. We didn't have to solve a squared equals 4 and then get like, oh, maybe it's plus or minus 2 and there's maybe possibilities. No, our hands were secretly tied. So let me put it all together. Step 3. Put it all together. In other words, the following algebra exercise, Jan, the following algebra exercise will work. A being 2. And where was A? A was above x plus 3. Don't swap those because that's your transcription error. Plus -1, that's what B was, over x plus 2. Put it together. This, Jan, is an identity which is true for, like, in the sense of algebra class. If you went and added up the right-hand side, cross multiply and do this, you would literally get the left-hand side. Go try it. And you'll find that you go in circles and you will write down this eventually. Okay, so you'll see how it traces back to the method when you actually combine these two fractions and witness for yourself this identity, this equality between left and right side. And now step 3. Step 4. 4 comes after 3. Exploit it. Exploit this decomposition. Because big scary integral, fraction integral, is now but chat in unison. What kind of integrals are these two pieces? Chat in unison. Eleni, 2 Elenis. Heleni, Eleni, Tori, Eleni, Shrek, Eleni, Macaco, Eleni, Hot Tamale, you're back, Eleni, Just a Human Guy, Eleni, Space Cowboy, Eleni, 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 Quick Brown Fox, Eleni, Fresh Throne, no, Flushed Throne. Glad to be back. Awesome. Glad to have you back. I'm glad you're awake. Dingy. Eleni. Eleni DeGeneres. Yes, exactly. That's where the word comes from. Yeah, wonderful. Yes. Okay, go Pokes. Eleni. Absolutely. So I'll zip to these answers. This is 2 ln x plus 3 plus, all right, plus -1, which is minus. And of course, now you see, it's all blue. We don't need to be in the red anymore. We can be nice and comfortable in the blue. All right? So, using this magic step, it's magic today, but tomorrow we'll be talking about how to implement this magic all the time. Okay? So right now this is a magic wand. There's a little bit of magic that happened. How did I know that I would be able to crumble like this before I even started? What gave me that confidence? How did I choose the overall template for how I'm gonna decompose? How do I know these things? Is it because I practiced and learned this stuff and did lots and lots of exercises and examples until it became second nature? Or was I born knowing? I was born knowing. But I'll try my best to explain it for all of you lay people. All right. With that, that's the end of today's lecture. Not bad, only 4 minutes over time. Now I'll go see what the heck happened in my chat. All right, so let's go. Now I'll go see what's happening. Okay. Missed the whole lecture. Algebraically challenged. Oh, algebraically challenged is a luminary. It's an important person. Don't want to mess with them. How do I do this? All right, there you go. Welcome, algebraically challenged, and welcome to the this family of degenerates here. Algebraically challenged is definitely an expert and should be respected, and you must behave in front of algebraically challenged. All right, there you go. That's right, Hot Tamale. You understood. You understand. You understand. Family of derivatives. That's right. We're a family of derivatives. Whatever that means to you, Atom Fighter 10101. Okay. Let's see here. Okay, lots. So let me go scroll up the chat real fast. Okay, so I see a wall of LNEs. That's understandable given the content today. Merely pretending. Magic is a rainbow color. Okay, I won't read the rest of that. Okay. Integral speedrun any percentage. Integral speedrun any percentage. I don't know how to read that sentence, but I'm sure it has meaning. Okay. Okay. Whatever. Oh my god. Macaco446 who participated. I saw you participating in chat. Though the quality of your participation is questionable because I think the only things I've ever seen you chat were Eleni and then once again Eleni. So I don't know, does that count as participation? I think not. But Macaco, you have redeemed Bike Till the Heart Explodes. Recorder has also been redeemed. So let me play the recorder real fast. And so what is it? What is hello Bungin? Welcome. Okay. And thanks to all those people who followed, like Jan. Great question earlier. Larry Weird. Hello. Welcome, I guess. Yin Gushi. Welcome. Let's find out. Welcome. Andrew, welcome. Agathon, welcome. Cosmic, welcome. Victor, welcome. Heisen, welcome. Oh, that Pikachu. That was 3 days ago. Great. Black Flash 10, welcome. Okay. So what the hell do you want me to play? Hi, Shadow Rider. Thank you. It's all real. Will you show the form this to confuse everyone? I think my class won't be confused. I think they understand the properties of logarithms, that you can write this answer and you can combine it into one logarithm using the log rules. So not my class ain't gonna get fooled by that. Okay, Kappa? I'm not gonna test it, but I believe in my class. Duel of the Fates. Okay, so you want to hear some Star Wars. All right. Well, luckily, I know how to play that, so that's an advantage choosing that. Okay. Okay. Ready? This is for Battling Storm. Duel of the Fates. Okay, ready? If you heard a little bit of screeching in the middle, I was just looking outside and there was a small tornado that some power lines went down. And so I think that might have caused some internet outages, and that fiddles with signal. But on my end, it was one of the best renditions of all time. So, okay. Okay. Oh, hey, Roosta. Thank you. Thank you. I'm not sure you were actually present, but yeah, thanks for the kind words. Thank you, Battling Storm. That was just for you. You redeemed that. And luckily the power went down and we couldn't hear it at all, says Kappa Klaus. Fantastic. That's the kind of chat I've got. Yeah. Thank you. Thank you. What software do you use for this infinite notebook? That's great. Actually, there's a command. Oh, Tropical Geek. Tropical Geek redeems just in time some shungite. So here's your let me turn the boring music on real fast. Okay, here you go, Tropical Geek. Here's your shungite for the day. Your shungite dose. And also for Bungin, let that save you from the 5G that that got in the way of your signal. Okay? Yeah, no problem, Tropical Geek, and welcome. Okay, so I gotta bike till the heart explodes, and that's how we'll end stream and lecture. And I'm so glad that everyone had a great time during part 1 of partial fraction decomposition. So what did we see? We saw live, right here on this channel, we saw 10 them wearing shoes. We saw first look at a partial fraction decomposition being used. We had a big scary fraction. It was neither clearly arctany nor was it LNE. Yet we still prevail if we have the power of the magic, which I just sort of pulled out of my hat. I somehow pulled out this amazing, crazy idea. Take the big fraction and split it up into 2 simpler ones. Why? How did I know to choose that particular kind of a over x plus 3, b over x plus 2? What motivated me? What light guided me? That I explain on Friday. And your homework, which right now looks like it's due on Saturday, is all about partial fraction decomposition and exploiting it, crumbling a fraction into smaller, noticeably easy fractions. It's all about that. And it's going to be actually due on Wednesday. So don't worry. Thank Labor Day. And some of you, apparently, are still celebrating Labor Day. Stop. Come back to class. Okay. Awesome. Wow. Okay. Great. Okay. All right. Oh, hello, Eric. Oh, Eric. Hello, Gath again. Yeah, everyone go check out Eric. Teaches computer science. Computers. Which I know nothing about. Well, Jan, you don't know. I mean, I'm really feeling it right now. So, yeah. The whole thing's a scam. Jan, the whole thing is a scam. This whole place is one giant scam. Okay? No. Both homeworks. Math Mama, great question. Both homeworks. Because I can't give a review homework which also has partial fractions in it. Right? So the review will also just default get shifted. Because the review has partial fraction as a reviewed technique. So I can't do that. That would make no sense. The wonderful question. The whole homework assignment will get shifted right after I go offline here. That's the first thing I'm going to do. And then I'll send out an announcement on Discord to confirm with everybody. But that's what happened. That is if... wait. Hopefully Kotz stops playing their game and... Oh, wait, what is this? Hot Tamale is playing something called the Spanish-American War. Is that a game or are you just learning? That's great if you're just learning. Okay, this is great. I love Discord. Okay. Whew, fantastic. All right, so okay. Now I'm just stalling. So let's go see. Where should we go? Where should we? Oh, hello, Nick Loop TTV. Welcome. Where should we go, folks? Where should we go? Where are we gonna go? Oh, Diatom's Attack. Yes. Diatom's Attack. Go say hi to Diatom's Attack and go check out some really cool tiny stuff. This is really cool. Actually really fun. Go check out Microscope. Okay, go spread the joy, the magic in partial fraction decomposition. The magic in this move. Go spread this joy. The joy you felt when I separated this like cell mitosis. You're gonna have to tell Diatom's Attack that you know this. Like that, I took a big cell and I broke it up into two little cells, like meiosis. Okay? That we did here.
Yes, science!
And we did it magically, marvelously. So go tell that to Diatom's Attack. Okay, folks? Please, be good ambassadors of what goes on here. Be respectful. Raid messages? Just spam, I love you. Just spam that. It won't be weird at all. Just go there, spam, I love you. There you go. Okay, Eric. Thank you for that. Thank you, Eric. Okay, go. Let's go. Go. Now.